everyone, it's December the 4th. Alright, let's take a look what we have today. Move pieces to obtain a string. Okay. Move pieces. You are given two strings, start and target, both of length n. Each string consists only of the character L and R and underscore, where the characters L and R represent pieces. Where a piece L can move to the left only if there is a blank space directly to its left, and a piece R can move to the right only if there is a blank space directly to its right. The character underscore represents a blank space that can be occupied by any of the L or R pieces. Return true if it is possible to obtain the string target by moving the pieces of the string start any number of times, otherwise return false. Okie dokie, so the first one is true because you can move L and move R. The second one is false because you need to move, okay, and the last one is false because R cannot make to the left. Okay, we have the idea of how this one is, and let's see how we can solve it. I think we are in the week of 2 pointers, so I'm going to start with 2 pointer. So basically, right, you can scan the second one from left to right. And if from left to right, right? And if you find an L and you find an L, yeah, so basically we have the target, right? So target the leftmost, the first letter, and then also the leftmost, the first letter in the start and the first letter in the target. So these two, if the target is an L and the start is an R, then that's not possible, right? So basically it's like this. We have a start, we have a target. So we go left to right, and then we first find an L. And if a start, also left to right, if the first find is R, then it's not possible because we cannot move a left past this R, right? Because you can only move if there's a blank space directly to its left. So this is not possible. So only possible is this L. However, if this L is to the left of this L, then there's no way to move this to the right because this is stationary. This one is to move. So this, if it has a smaller index, that's also a no-go. So an only go is if it's an L and then it has a larger index, right? Larger or equal, right? Or equal index. That's the only condition that it will match. And if it match, we move on to the next one, right? And for each position, I think we are checking exactly the same thing, right? Because the next one is the same, right? If it's the R, but this one is an L, then that's not possible. If it's L, but it's to the left of this L, then that's also not possible, right? If it's L to the right, then it's possible, right? Then it's possible. And we can also do R. Same thing, if it's an R, but we have an L, that's not possible. If it's R, but it's to the right, right? If it's have a larger index, that's also not possible. It's only R if it has a smaller index. Now that actually not really true, right? Because if I have an R here, and then we have an R in the start here, but because I need to move here, but if in between we have an L in between, then that's also not good, right? So I think I need to do 2 rounds. 1 round is left to right. We just run through it. You can even left to right only focus on L. You don't even have to know about R. Because left to right, I have space for L to move. Right? I know that there is space for L to move. Actually, yes. I know there is space. So we can go a left to right, we focus on L. And we do a right to left, we focus on R. And then, yeah, that's about it. Okay. Shouldn't be too hard. I can foresee that perhaps in the solution we will have a 1 pass. But I am not interested in 1 pass for now. I think 2 pass is very easy to code up, and I'm just gonna go 2 pass. Both of them. My God. They are bag cat. Oh, you should take a picture of this. All right, so we have 2 passes, right? We have a left to right pass and a right to left pass. So we can say left to right, focus on L. So what do we say? We say for int I equal to yep, 0 I smaller than say star dot length I plus plus, and we need a can we do 2 for loops for this? I don't think so. I think we need to say j equal to 0, right? And then say while, make sure you end at a, so j smaller than target dot length, right? And target j is not equal to underscore. Is equal to underscore, my bad. Is equal to underscore, then j plus plus, right? So now j is at a thing, and you need to say if start I is not equal to underscore. This is when we do the comparison. So what we say is if start I equal to no, we are focusing on target, but we should also focus on yeah, we should focus on, so we say the target is L, right? Then we check, yeah, let's focus on target is L. Like we don't worry about but target is R, we can worry as well. Hold on, maybe we can do it in 1 pass. Target is R, right? And then you are L. That is a bad. Target is R and you are R, and you are to the right. That's also bad. So target is R and you are R, but you are this. We can temporarily consider that is good because we, hold on, are they the same size? Yeah, I think temporarily we can consider that's good, but we don't know, right? If okay, let's say we have this case. Okay, it's actually, we probably can do 1 pass. Let's say we have the target, okay? We have R. And then in the start, we have R here. Okay, so to the left. So that's a good thing. But let's say we have, you know, another R here. I have an L here, right? And it's kind of getting blocked. And then if this will go on, if it's an R, then we'll fail, right? But if it go on, it's an L, that will also fail because this L is like, we can say, okay, this may be good, but this one will be bad, right? So regardless, if it's L, then it will fail no matter how this one is. It can be an R, it will fail. It can be an L, it will fail because it cannot reach. Now, if here is an R, and then we have an R, then yes, then we can still say it's possible. But if it's an L, then it's not possible. So let's just try one pass. Let's try one pass. Maybe one pass is enough. Okay, maybe one pass is enough. So we stop here, and then this again, we stop. So now both are, right? So we can say if this is not equal to target J, right? Then immediately we return false. Okay, they have to be equal to begin with. So now they're equal, okay? Now they're equal, then we shall say, actually we can do this. Or start I is equal to L, right? Basically both L, and I is smaller than J. All right, 0 to more to the left, so that's also bad. Or start I is equal to J, to the right, and I is larger than J. Right? So in any of these situations, it will do this. Right? It will do this. Otherwise, you just keep going, and then we'll return true if nothing happens. Okay, give this a shot. Give this a shot. Let's see. Use test case. Does it work? No, it does not. That is not good. Not good. All right. Why is the first one not good? So J is equal to 0. It's equal to, so we keep going. So I is equal to L, right? So start I is equal to L, and I is smaller than J. I is not smaller than J. So this one pass. So now we go to here, right? I is here, and then J is here, and I is larger than. I do not know why it doesn't work, but hey, we can debug again. I'm very excited about debugging these days. Okay, so what do? We say std string start equal to what's that? It's this. All right. Oh, the hell is this? Dear me. That's okay. Do not panic. We'll figure this out. Std string, okay, target equal to this. Okay, delete this, and then this function should be can change, and this should be start and target. All right, we'll save this. We'll set the breakpoint. Come here to C line plus plus, make the change to the make the change to the date should be 5. Do this, come here, do F5, go up, go. There we go. Nice. Look at this. Look at this. We can debug it. Okay. F1. This. Okay. So j shall equal to 0, and it's false, right? I is false. So keep going. Jump. Yeah, I saw jump. Yeah. All right, so I is equal to 1, j. Okay, these are equal, and this shall not return false. Oh, good. Not return false. Keep going. Oh, I think you forgot to increment j. Yeah, I think you forgot to increment j. Oopsie doozy, my bad. Okay, we need to increment j. So if this is the case, if we complete then j into plus plus here as well. Okay, so let's try. Basically what I'm saying is after this, j plus plus. All right. All right, looking good. Let's write some stuff for this. All right, so this is 2337. 2 pointers. When we go from left to right for both pointers, when both pointers point to a non-empty letter, we check. If they are not the same, right? They are not the same. It's impossible to make the change. If they are the same, depending on the relative position between I and j and the current letter, right? We have different outcome. If start I, if we are talking about L and I is to the left of j, then start I will never be able to reach the position of j. Thus, it is impossible. Similarly, if we are talking about R and I is to the right of j, then start I will never, then it is also not possible, right? Then it is also not possible. So, so on, okay. Now run one more time. Verify it's good. Let's see. We got a wrong answer. Did not consider that. Did not consider that. Holy crap. So shall return j is equal to target.length. Alright. Did not. Absolutely did not think about that. Okay, try it again. That was Jimbo, not you. Oh my god, this is bad. The hell? Oh my goodness. Bunch of L's. A bunch of... Wait, hold on. Why does this not work? So, J will be a 0, and then blah, 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 blah. We'll go to the first, and then I is not smaller than J. So they'll keep moving, J move forward, I move forward, right? And then they both move forward. And then it was good to move forward and move forward and move forward and move forward and move forward. And it gets out. Oh my god, I didn't realize I should do this. Yep. Shall do this one more time. Dear me. That's a good test case. Completely not. Did not pay attention to that scenario. Yeah, I should have realized this. That's okay. That's okay. I mean, yeah, I forgot that this J needs to move to the end, right? Okay. Third time's the charm. No hay quinto malo. La tercera es la venganza. Wait, no. No, not venganza. La tercera es la vencida. Right? La tercera es la vencida. Sí, es la vencida. Or no hay quinto malo. Okay, that's good. 12 milliseconds, 50% of... Let's take a look at the official solution for this. Brute force, yeah, of course, brute force won't work. Using Q, that is interesting. How do you use Q? Let's just read this. I mean, the good part of reading this is you kind of get a glimpse of how C++ works. Yesterday, I just learned that there are lambda functions in C++. I did not know that. It was not a new feature. It was added in C++ 11. So we actually might have encountered it when we were in school, but I never used it. And I saw it yesterday. I was like, wow, there's lambda in every language now. And here we have this pair. I didn't know there's pair before. So we have pair. Q. Oh my god, this is what's it called? Declaration, right? Yeah, I forgot I can declare this way. Non-underscore character. So we put non-underscore into it. Oh, the character and the position. Good. That's a good check. Stark is not empty. Use auto to get it out. Use auto to get it out. So if they're not the same, or this, yep, that's the same exactly what we're doing, return false. Otherwise, return true. That's good. 2 pointers, right? That's 2 pointers. So 2 pointers, while and a while. You do while and a while, so you don't have to do this at the end. Yeah, that's okay. Okay, so that was good. Good problem. All right, let's try this one more time. And we had the solution actually. So we can do this. Oh, we're redoing it. So we actually going to use Python for this. Where's Python? Where's my Python? Here. 2257. Okay, 2257. Let's do this. 2257. 2257. All right, so we're gonna redo this in Python. All right, so I think I know. We need to create a grid. Oh my goodness, do you remember how to create grid? Oof. Oof, that was rough. All right, hold on. We have to say guard is 1. Wall is 2. Yep, that's it. Guard is 1, wall is 2, empty space is 0. So we'll say 0 times, my god, n for this in range m. Okay, so I got all that. Then what? Then we say for ij in, so guards is an array of array, right? So we have to say for row in guards. Wait, hold on. What is guard? No. It's good. It's good. For ij in guards, right? So I'm gonna start from ij and then start to go bananas. Walls. All right, I think I need to go walls first. For ij in, no, jump. Walls. In grid ij equal to wall. Okay. And then we can go this, right? And we can say horizontal, right? Horizontal. How do you do for horizontal? You say, well, hold on. First, you say grid ij equal to guard, right? And then you go horizontal. Then you say for k in range, horizontal I and j. So j plus 1 all the way to n, right? If grid ik is not equal to 0, is not equal to 0, then you break. Otherwise, grid ik equal to guard. Okay. So horizontal also for k in range. From j minus 1, right, all the way to 0. Again, if grid ik is not equal to 0, we'll break. Otherwise, grid ik equal to guard. Okay, now we're gonna do vertical. Okay, in range I plus 1 to m. If grid, this is where ChatGPT's type of stuff will be very helpful. Because I'm just repeating myself. kj go to guard. Alright, last one for k in range. I think it's I minus 1. Oh, range is spelled wrong. I minus 1, minus 1, minus 1. If grid kj is not equal to 0, break. Grid kj equal to guard. Okay, so we do that. Once we're done, we say rest equal to 0 for in grid for E in row. If E is equal to 0, rest plus, I think I can do rest plus equal to E is equal to 0. I think I'll do automatic. Oh, we can do this. Return sum E is equal to 0 for row in grid for E in row. All right, let's take a look. Does it work? No, it bloody not. The hell, man. We set the wall. And okay, don't worry. I just debug. We only have one test case for this one. We have this is the test case. Okay, so this is the test case. Oof. Answer shall be what? Answer output 7. Okay. Oh, so this is M N guards walls. This is count unguarded M N guards and walls. Okay, we're not gonna run this. What we're gonna do is, you know, set this debug. I love debugging these days. Oh, I just realized no. Let's not debug this one. Probably it's easier to do 2257. Probably easier just to run it. Result 8. Yep. And what we need to do is to check for row in grid print row. All right, let's see. 1 2 0. Oh, that is correct. Because you go this first and then you ignore this. Huh. Okay. So to prevent, so if you're in the horizontal, if you're both on horizontal, then you should stop the first time you hit something, right? Maybe we need a horizontal marker and a vertical marker. Yeah, because here you get blocked, but that's a horizontal block. Okay, so guard row, guarded row, guard row 3, guard column 4. Okay, so we got wall, we got guard, and we say if it's not equal to, so we're gonna do horizontal, right? So horizontal, the one when you drop out is if it's a guard, a wall, or a column. No. Guard, wall, or row that you drop out, which means you will say if it's equal to 0, okay? So equal to 0 or grid ijk is equal to, yeah, let's not call it 0, let's call it empty. Right, so basically we say if it's equal to empty, empty, or if it's equal to guard column, right, then you do this, okay? Otherwise, you break. And I think this is exactly the same here. Right, so that's good. And here I will do exactly the same by saying if grid kj empty or grid kj is equal to guard a row, right? Then we say grid kj shall equal to guard column. Actually, these are not guard row. Else we're gonna break. So now this we can do. Okay. Let's see. This one pass. Well, this is a simulation method from the official solution. We start from, we use a grid, right? We create a grid, right, for simulation. First of all, we fill in all the guards and the walls. Then each guard we go horizontal, and fill as many cells as possible. Right. We stop, right, if we hit another guard or a wall. Or a cell that has been horizontally guarded. Then we go This is actually giving me some pause. I don't think we should do it at the same time. Maybe it's fine. Maybe it's fine. We go horizontal and then we go vertical. Horizontal, it won't be affected. Vertical, yeah. Then we go vertical and follow the same pattern, same method. So this is only OMN. The worst case, it's O2, like, yeah, it is OMN. Okay, run it one more time. Make sure we don't include this. Submit it. I was using Python in the past. It's very simple, right? Very, very simple. It was a little bit disappointing that I remember that day I got a little bit stuck. Right? It took me a while to get it rolling. So you see, it's actually faster than Java. Yeah, Java solution was pretty bad. All right, so we're done with this. We can turn it off. And actually forgot about how this one is solved. I forgot. I remember is dude, I forgot. Jesus. I remember is you go, this is the height, and remove a query. I remember the problem, but I forgot the solution. Remove a subtree rooted at a node with a value. So we want to remove, and after remove, you want to know the height, right? The current height. I think it is oh my god, I forgot. Left and right traversal. You do a left traversal to find the height of each tree, right? Okay, we can track the tree's height as we traverse from the root. For any node, the height after removing its subtree is simply the height of the tree. The height of the tree before reaching that node. Yes. Yes. So if we do a right first, yeah, if it's a left subtree, I will want to traverse everything on the right before hitting this one. So we do a right first. Then we know when we hit this, what is the current height. Then we know when we remove this, it's gonna be this, right? And if it's a right subtree, then we need to traverse the left first. So for each one on the right, so you're gonna do left first, and then you go back up, and then you're gonna go right. So what is the current height? But we haven't traversed. So doing a left traversal, before I hit this, I have the height, this is the current left. And I will do a right traversal, and I have a height when we hit this. right? We have all the right, and then we just find the maximum of the two. Yeah, I think we just find the maximum of the two. Okay. I can try it. I don't. Is this really the solution? It should be very simple, right? So we do a left. We do a left and a right traversal. Left to right, right to left, and then we have the maximum height. Then we do a maximum. Yes, I'll do the exactly same thing. Yep, I think that is a solution. Okay, we'll do this some other time. All right, I'll see you guys tomorrow. Adios.